Hi everyone, this is Mrs. Markley. I just wanted to put together a short little video that shows kind of the basics of what this Apollo Autonomous Code does. If you're like me, it looks a little overwhelming, so that's why I wanted to put a quick video together to help you understand the basics. So when you open up the Apollo Autonomous Code, you can kind of scroll through, and there are a lot of lines of code, a lot more so than when we worked in Python. And so, a lot of this, I'm going to be perfectly honest, I don't know what a lot of this does. Mr. Cross certainly knows more of it than I do, but as you look at this basic setup, you can see there's only a couple pieces of code that we really are going to pay attention to. One of those areas in this particular unit and upcoming units that we're focusing on is what is called this void autonomous section of the code. And if you think about how that connects to what you've done in Python, I would think of this as kind of like our def main. And this is the main function that's going to get called, or in this case, it's called a variable. This is the main variable that gets called when, and I'll scroll back up here so you can see where it's at. When we push triangle, so I might have to do a Command F. I'm going to do a Command F to find triangle. There it is. All right, so right here in the code it says if PS3 get button click triangle. In other words, if we push that button, this line right here where it says autonomous tells it that everything that's recorded in our autonomous program is going to get executed by just pushing the triangle button. So within autonomous, right now, when we push that button, the only thing that's going to happen is it's going to drive forward for half a second. All right. What you're going to do in your autonomous code is basically use these. I have three. I'll talk about this third one here, a little bit later when we talk about the delays. But this part of the code is really just running the drive forward and turn left features. And so what I'm going to do is in my autonomous code, just going to come in right here where it says drive forward. Go to the end of that line, and I'm going to, after it drives forward, the robot will need to turn left, and we called our variable turn L, and then in parentheses you're going to tell it how long to do that. So I'm just going to make up a number, say 3.53 seconds or 3.52 seconds. All right, after you tell it to turn left, semicolon. And essentially, we just repeat this process multiple times for each time the robot has to go forward and turn. And so I would just literally copy and paste this in 4 times. And the last turn really isn't necessary. So you can eliminate that. Once it arrives at the destination, it doesn't have to turn back to the origin. So this right here would essentially make the robot draw your quadrilateral. Some students noticed that the movement was pretty herky-jerky, so I'm just going to delete this for just a minute. And so one way to kind of help that herky-jerkiness is if you create another variable. And what I mean by that is another one of these void thingies. All right, you're just going to copy one of these voids, including the closing bracket. And I'm just going to paste it in somewhere above my autonomous variable. And if you were to run this code as it sits, the autonomous code would work. The only problem is, 1, we haven't adjusted the numbers here for what we calculated. And 2, we need to call it something like wait or pause. And by doing that, we can incorporate this command or this variable into our autonomous program, and it'll make it a lot less like herky-jerky. In order for it to actually make the robot stop, though, these right numbers need to be at 90. And by locating them at 90 there, it essentially makes the motors stop. Okay, if you want to know why, come talk to me, and I'll show you visually why that happens. But now that we've called the variable wait, between every drive forward and turn left, I'm just going to slip that baby in there. I'll call it wait. And if you wait like half a second, that should be enough time to make the robot, not jerk around so much. And then make sure you put your semicolon at the end. So I'm going to copy that line of code and put it in between every turn and drive forward. All right, and by doing that, excuse me, by doing that, now you can see it, the wait command slows the robot down and tries to keep it on path a little bit better. All right. Again, realize that each of these numbers in the parenthesis will change based upon what you guys come up with for your delays in the engineering packet. All right, hope that helps.